what I hope to do in this video is start with an exponential expression that's in a fairly straightforward form, and then turn it into one in a hairier form. And let's actually just do it. I'll show the initial expression in the form that I want it in, or that we want it in, and then we could talk a little bit about why would we ever actually want to do that. So let's say my expression is 1/32 times 2 to the t power. So this is fairly straightforward exponential expression. But let's say we want it in the form a times b, and this is where it's going to get hairy, a times b to the t over 10th power minus 1. And so you're probably immediately saying, well, why would I ever want to take something nice and simple like this and turn it into this beastly thing right over here? And the answer is, when you get into higher math and you start doing your physics and your chemistry, you're going to see maybe, you got a result like this, but then you look in your textbook or your professor, it has a result like this. You say, well, how do I transfer from this to this? Or actually, sometimes when you transfer to a form like this, obviously I've just arbitrarily written this form here, but sometimes when you write it in another form that might even be a little hairier, it can give you an intuition on the underlying processes that that expression is trying to describe. So if you can take that on a leap of faith, let's actually try to do it. And at minimum, it's going to make you a lot better at exponent properties. So see if you can rewrite this in this form. So I'm assuming you took a go at it. So let's try to do it together. So the first thing that I might want to do is, well, let's see if we can. Let's see, what would I want to do? The first thing I want to do is take this t and get it into a t. Let's get it into a t over 10. So to do that, we essentially just need to multiply by 10 and divide by 10. So let's multiply by 10 and then also divide by 10. Then we haven't changed the value up here. So we can rewrite this. We can rewrite this as 1/32 times 2 to the, so let me circle t, let me do this in a different color, t over 10 times 10 times 10. All right, so we got a t over 10 over here, but then I have this times 10. So how do I deal with this? Well, one thing that I could do, let me actually just write this the other way around. Let me write it as 10 times t over 10. 10 times t over 10. So hopefully what I just did here isn't a huge stretch here. I just literally multiplied and divided by 10, so I have this t over 10. But when I write it this way, an exponent property might jump out at you. If I have a to the b, and then I raise that to the c, that's going to be a to the bc. Or another way around, a to the bc is going to be a to the b to the c. And so this piece right over here, I can rewrite it as 2 to the 10th, and then raise that to the t over 10 power. To the t over 10 power. Once again, 2 to the 10th, and then raise that to the t over 10. That's going to be the same thing as 2 to the 10 times t over 10. And of course, we still have the 1/32 over here. 1 over 32. And I'm tempted to write that as 2 to the negative 5th power, but I won't do that just yet. So let's see. What's 2 to the 10th power? Actually, let's just keep it. Let's just keep it as 2 to the 10th power, just for simplicity right now. Later we can, you might know that that's going to be 1024. But let's see what else we can do. So we know this is going to be actually, let me just write it out as 1024. So we have 1/32 times 1024 to the t over 10 to the t over 10 power. So it seems like we're getting close. If there was no minus 1 here, we're essentially done. But now there's this minus 1. So how do we deal with that? Well, we can do a similar type of strategy. We can subtract 1, and then we could add. And then we could add 1. Then we're not actually changing the value. Just as we multiplied by 10 and divide by 10, we're not changing the value up here. If you subtract 1 and add 1 to the exponent, you're not changing its value. And so what is this going to be? We want to leave this minus 1 here. but we want to get rid of this plus 1 somehow. And here we just have to remind ourselves that if we have a to the b times a to the c, that's going to be equal to a to the b plus c. If you have the same base multiplied to same base raised to different exponents and you multiply them, you could just add the exponents. And so you could also go the other way around. If you have a to the b plus c, you could break it up into a to the b times a to the c. So this business right over here, this is 1024 to the t over 10 minus 1 plus 1. So we can break this up as 1024 to the t over 10 minus 1. That's this part here. And then times 1024 to the 1. Times, let me make this in a different color. So let's see, green. So this right over here. So times 1024 to the 1 power. That's this 1 power right over here. And of course, we still have the 1 over 32. All right, so now we're really close. We have the 1024 to the t over 10 minus 1. We have t over 10 minus 1. And now we just have to simplify. We can rewrite this is going to be equal to, we could just bring the 1024 to the first power. That's just 1024. So that's going to be 1024 over, I can put all these commas here if I like, 1024 over this 32. Let me do it in that magenta color. Over this 32 times, home stretch, times 1024 to the t over 10 minus 1 power. And now we could just simplify this. You might recognize 1024, we already saw that was the same thing as 2 to the 10th power. 32 is the same thing as 2 to the 5th power. So 2 to the 10th divided by 2 to the 5th, actually this is another exponent property at play here, although you could just divide the numbers. If you have a to the b over a to the c, this is going to be equal to a to the b minus c. So this is going to be 2 to the 10 minus 5, or this whole thing right over here. This thing, actually I wanted to do that in a different color. This thing is just going to be 2 to the 5th power, or 32. So this is going to be 32 times 1024. We're in the home stretch here. 1024 to the t over 10 minus 1. So once again, normally in our lives, we like to make things simpler, and I'm a big advocate of that. It's a good life philosophy. But this is a case where we really did make it more complicated. We started with 1/32 times 2 to the t. Actually, we could have, well, there's other ways we could have written that. And we turned it into this thing with this somewhat hairier exponent, but it's a useful skill to have because you might get a result like what we originally started with, and then someone else might get a result like this. And it's very important to realize, hey, you actually got the same result. They're just different ways of expressing the same exponential expression.